All right, let's look at number 8. At the end of the summer, I decided to drain my swimming pool. The pool was full with 1,500 gallons of water when I turned on the drain. Water starts flowing out on the ground at a rate of 2.5 gallons per minute. Right here, this should be a big indicator of something that will help me. I can use this equation to find the amount of water W in the pool after m minutes. Well, if it's draining at 2.5 gallons per minute, that to me sounds like a slope, right? That sounds like a rate of change. So I know this is probably going to be linear. And if I put this into Desmos, I see that this is linear. Okay. It's hard to see because it's draining very slowly. But if I know this is linear, then I know that this is y, and I know that this m is x. So it'll really help me know what's independent and dependent. And really, you know, we're talking about time, minutes, right? And we're talking about the amount of water. So right away, what depends on what? The water is going to depend on how many minutes have passed. So I'm going to take my text box. Independent is the time in minutes. And what is the dependent? It's the amount of water. So the water depends on the minutes. So then I'm going to go and put this into Desmos, and I want to see what's W of 150. So I'm going to put W of 150, and then I get 1,125. And that seems kind of high, right? It was 1,500. I'm draining. I would expect it to go out faster. But even looking at this line, it shows me that it doesn't drain very fast at all, right? So that answer, you know, when I'm thinking in my head a good answer, that is a good answer. 1,125. 1,125. Now I want to put what that means. So what is that 1,125? So there will be 1,125 gallons of water after 150 minutes. And there's my sentence. Let's go to number 9. Grandma Openlander just purchased her first prepaid cell phone with a balance of $75. Every time she makes a call to talk to her son, she spends 15 cents. So she has the balance of 75, she makes a call, 15 cents a minute, right? As the minutes go on, what's changing? Her balance, right? We can think about that problem before we even look at the equation. So this equation gives grandma's cell phone balance B after speaking for M minutes. Big one, time. Again, I see time. So does the balance depend on the minutes, or do the minutes depend on the balance? The minutes aren't going to change, right? As my money changes, my money is going to change as the minutes go on. As I use more minutes, I'm going to lose that money that's the balance. So the independent, again, is time in minutes. The dependent, what's going to depend, is going to be my phone balance. Okay? Plug it into Desmos. It's asking B of 80. What does that mean? It's saying the balance after 80 minutes is 63. So, and if I look at this on the graph, my x-axis, we know it's going to be 0 because it's a real world problem. We're only going to be looking in quadrant 1. My y-axis is going to be 0, 2. I started at 75. Whoop, not that high. I started at 75. So there it is, right? So B of 80. B of 80. Wonder where that would be. So here we go. We start at 0 minutes, $75. And as we continue on, we have 80. Oh, we're going to have to go over here. At 80, what is that? 80 minutes, the balance is $63. So that would be my sentence that I write right here. So after 80 minutes, the balance is $63.